we are going to preheat water. Okay, so for that we'll be using this coal to heat the water in the boiler, and the vapor will be produced, and the vapor agitation will be help us for the turbine, and the turbine is connected. So that is normal working operation of a thermal power plant. So that ideology will be used in the steam cars. Okay, so where we'll be using the amount of water, and we want to heat the water, and this particular thing we want to create the mechanical energy. Okay, so ultimately we want to develop a mechanical force. And next one, what we presently using is the IC engine based cars. Okay, so initially, so once the IC engine based cars was developed initially, okay, and even now we are having one more factor of noise. Okay, so that has been alleviated by the silencer, and then initially it has the difficulty of the starting, and later they developed the starters in 1912. Okay, by the Charles King. So he developed the starters. So in the machines subject, we normally study about the 2-point starter and the 3-point starter. So after the development of starter only, the difficulty of starting has been normalized. Now we talk about on the electric cars. Okay, so in this electric cars, there are two major drawbacks. Okay, so here we are going to talk about on the two major drawbacks. Okay, so that drawbacks will be on short driving range and also poor battery performance. Okay, so the battery performance is quite poor. Okay, so that is the reason in this FTP we are going to address this battery performance. Okay, and then we are going to talk about because these electric vehicles are much suitable for the short driving range, not for the long driving range. It's useful for only the short driving range. So with this perspective, we are going to discuss about how to overcome these problems and all in the electrical perspective. So we want to know the definitions for the various vehicles. Okay, so when we talk about on the electrical vehicle, why it is called as a EV? Okay, it is called as a EV because it makes use of electric motors. It makes use of electric motors. Why it is used to electric motors? For the propulsion. So for the initial starting, we want some propulsion, so we use the electric motors. Since we are using the electric motors, it is called as an electric vehicle. Okay. And then the battery electric vehicle means, so when it is powered by battery, it is called BEV. Okay, so when the vehicle is operated by both battery and also IC engine, we call as a hybrid electric vehicles. What we talk about. Okay, so when we talk about which is having the battery and all battery EV and also IC engine, we call as HEV. And next is called as a PIV. We call that as a plug into the grid. Okay, so I will be talking more on the grid in our Thursday class, so some of the research problems, what we are doing for the grid interaction. So these are some of the examples what we talk about on the electric vehicle. So we have, as I already mentioned, we are going to discuss about on the various, let us talk about on the various factors, and we talk about on the, let us talk about, various comparative analysis of the motors and comparison of the various things, so we are going to discuss about on the case. So here we are going to talk about on that particular aspect. So the examples of electrical vehicle, we talk about on the Chevrolet or Mitsubishi EV based vehicles. So I'm not going to talk about on the theory. We go only on the technical items. So theory, I just to skip just by giving only the salient points. So the benefits of electrical vehicle, we talk about on the less emissions. Okay, and is also having some quite satisfaction. So whenever we talk about on the electric vehicle, we're having the much more satisfaction. So that is the various aspects when we talk about on the electric vehicle. So here, okay, so here we talk about on this electrical vehicle. So with this particular thing, we normally connect, so by reducing the emissions and also by making the higher satisfaction, we normally talk about on the electric vehicle. So as I already mentioned you that this EV makes use of an electric motor, which is having the efficiency of 70 to 85%. And also when we compare to the engine, the efficiency of the engine will be sufficiently some numbers, not on the percentage what we talk about of the greater than 70 to 80%. And the EVs can make use of the regenerative stopping effectively. Even IC vehicles, we make use of the regenerative stopping. What is meant by regenerative stopping? Regenerative stopping means, the energy that was produced during the operation of the vehicle, whatever the energy that has been generated at the load side. So the load side generation of the energy, which will be redirected to the source side. And again, we are reusing of the energy. Okay. So during the stopping, during the operation phase, once you stop, how you are making use of the energy that has been delivered by the load side. We normally talk that as a regenerative braking. Okay, and we say that these electric vehicles are quite environmental friendly. So mostly EVs can be used in the all the different types of vehicles. Now we talk about on the, as I said, the electrical vehicle is going to be is a very old story. Okay, so now for many of the researchers, okay, whenever we start the research, when I started the research in 2009. Okay, so I asked the question about myself, in what area I need to start my research. At that time, everybody are talking about on multi-level inverters. At that time, okay, even now also, few of my research scholars, they are doing in the area of multi-level inverters. So at that time, it is very popular. Multi-level inverters like cascaded and diode clamp and flying capacitor. Many people are completed the PhD in the electrical domain with this particular multi-level inverters, 5 level, 7 level, 9 level kind of. Okay. And later on in the electrical system, the people have been migrated their works related to electrical machines. Okay, they worked with the torque control, they worked with the flux control, vector control, and reduction of noise in electrical machines kind of. Now, presently, we can able to see some kind of vacuum space, in the research area, because you can be able to see whatever the area the people are taking, they have a gentle feeling that the work, whatever they are doing, it has been already done by many peoples. So every journal, whenever you submit a paper to any of the journal, the first question the journal people asking is, what is the novelty of your paper? So it is very difficult, for many of the researchers to find a novelty. So many people are moving towards on the review papers and writing some simulation papers. So when you're going for the work paper, all the work paper, when you want to publish an IEEE or IET or LCB or a Springer, so they need some kind of novelty. But I will tell you what are the new novelty which we have done. I will also share some of our paper publications, what we have done in the recent years in 2024 and 2025. Okay, related to electrical vehicle. I will be giving you a list of papers, what we have done, and I will also cite out what is the novelty which we have done for the battery management system. So as I already mentioned you, this EV is not a new story. It is a very old, very old story. Okay, actually the electrical carriage history was started in the year of 1832. So in my book, what I've written a detailed history, but for the sake of presentation, I've given you only the salient points. Okay, only the salient points are listed in the presentation, but the detailed version of the history is given in the book. Okay, and then we talk about in the 1835, that is a year we speak about on the first practical electrical vehicle was built. Now we are in the 2025, so soon we are going to reach the 2035. So we can able to see that it is a electrical vehicle is a nearly 200 years old. The concept of electrical vehicle is 200 years old. Okay. Now still we are making one FTP and we are going to talk about on the technology. The technology was developed 200 years ago. Okay, we are again reiterating, we are again rethinking, we are again reusing the same concept. But you should understand that before 200 years, what kind of ChatGPT, what kind of things are available those times? We don't have any other thing, because we can able to imagine that nothing has been available at those times, more than 200 years. But we expect to do something, the electrical vehicle. Normally, my first research problem, what I can see somebody has made a, okay. So if you have any queries, you can able to put in the chat box. Okay, so I can able to get some pop-up message. So the first and foremost research problem, how to make use of electrical vehicle suitable for Indian roads. Okay, that is the first research problem. Okay, so where we can able to understand, so whenever the Indian roads will be having so much of jerks, suddenly you have to make a very strong agitation. Okay, sudden brake will be a common. It is not uncommon; it's a common. Okay, and we'll be having so much of ups and downs. Okay, and how to tackle all these factors. Okay, for an example, whenever you're going to a shallow deep, and then again you want to climb the hill. Okay, you just to think about how much of energy or how much of potential needed by the battery to do this operation. Okay, for an example, engine can pull up. Okay, because we are going to exert this engine. Engine is made for that, but we are going to replace the engine by a motor, and this particular motor, even though it is having the higher efficiency, I want to give a sufficient energy and also sufficient power. Okay, which we normally call as a specific energy and a specific power. Okay, so that specific energy and the specific power, it has to be provided by the battery. Okay. So how the battery will know, even how the battery can able to understand the nature of roads. So that is the first research problem, how to make an electrical vehicle suitable for Indian roads. Okay. And we want to see the performance of those electrical vehicles. Okay. For an example, if you purchase a normal IC vehicle, okay, it will come for 10 to 15 years. Then we put for FC, 5 years plus. Again, you FC, 5 year plus. The vehicle will look old, but you can able to understand that you can able to use the vehicle for 20 to 25 years. But the electrical vehicle, what it has been given now, okay, how it can be suitable for Indian roads? That's a question number one. So this is the first problem. Next one, we talk about on the electric current that was being generated, that was first given as a concept in England in 1840, and this has been received a patent how to drag the wheel with the help of the DC power supply. Okay, where this particular having the two coils having the positive front and the negative return, which is marked in the green color. And then we can able to understand that, the rail, okay, or the platform or this particular area. So where we can able to see that this is not connected electrically, it is not connected. So it works basically on the power supply and then drag the reverse power supply. So enough force from the DC power supply. So this particular concept has received the patent. And then we say that, the lead acid battery, it was started in the 1859. Okay, so it is a quite rechargeable battery. Okay, normally the battery are classified into two types. One is called as a primary battery, and another one is called as a secondary battery. So primary battery will be called as a non-rechargeable battery. Okay, what we are using in the remote control, what we are using in the television remote. Okay, so once it is work completed, we'll throw it off. Okay, so non-rechargeable battery. Secondary batteries are also called as a rechargeable batteries. Okay, where we can able to recharge. Okay, but here the secondary batteries or the primary batteries, we quite talk about on the number of cycles by which it can able to work. Okay, cycles means the cycle consisting of two things. One is called a charging cycle and one is called a discharging cycle. Okay, it is quite just like a sinusoidal waveform. So charging and discharging. Okay, and I will also explain you how you need to charge your mobile phones, how not you should charge the mobile phones, how to charge the laptops. We'll be discussing in later. So we can able to understand the charging and discharging cycle. For example, when you purchase a battery, it will be having your data sheets of the battery. In the data sheet, they will be specified that it will work for 3000 cycles. So this is the cycle number one. Similarly, it will work for the 3000 cycles. At the end of 3000 cycles, the battery will fail because it completed its life. So in our work is, in our research problem number 2 is how to extend the lifespan of the battery. Okay. For an example, if you maintain the battery appropriately, it will come for 3000 cycles. If the battery is poorly maintained, or if the battery is quite faulted or dented or rusted or corrosive in nature, it will not come across, or it will not even live for the 3000 is how we are see the battery. For an example, if you take one battery, okay, for an example, a physical battery you are seeing from your eyes, okay, by looking at the battery, how can we say that how many cycles it completed and how many cycles are yet more bending? Nobody knows. It also requires a load pattern. Okay, how much of load pattern is connected to the battery? Who knows the load pattern? So here in this particular thing, we collect some kind of data patterns. For a new battery, we collect the data patterns on load cycles. Okay, we call that as the discharge cycles. In the MATLAB, we can able to, I will also show you the MATLAB simulation of the discharge curves, for the different ampere levels. So based upon that particular thing, we can able to estimate how long this battery will live. That is called as a battery management system. Battery management system is, I want to manage the battery to see how long the battery will survive. How long the battery will survive. Okay, when the battery will going to die. Okay, that is called the real battery management system. Normally, many of the students who are coming to the final year, they will say that, sir, we want to do some project in battery management system. And we say that, yes, you can do the project on battery management system. So they will start the work. And finally, what they will show on battery, they will measure the voltage, they will measure the current, they will measure the temperature. They say that, sir, this is the battery management system. That is wrong. That is not at all a battery management system. That is not. And some peoples, they will do the same projects, in the battery. They will connect some sensors and they will throw the data into the cloud, and then in the IoT-based system, they will display. In the display, we can monitor the voltage, we can monitor the current, we can monitor the temperature. They say that, sir, this is the battery management system. That is not at all a battery management system. Okay, that is only a monitoring device. Monitoring is one of the part in the battery management system. Don't confuse. See, whenever you are working with any problem statement, don't confuse the problem statement. Okay, and many people may be working with the power quality, but many people does not know that where to measure the power quality. Where to measure? We know the place. These are the places you have to measure the power quality. Normally, you should not measure always in the output voltage and say that my power THD is reduced to 5. No, that is not the right approach. We have to measure the suitable place prescribed for measuring the power quality. Okay. Similarly, since our focus is on the battery, okay, just measuring the 3 parameters alone is not a battery management system. So that is the research problem number 2. Okay, the research problem number 2 is how you get the data regularly, okay, and based upon that, how you are going to tell the present status of the battery, how many cycles it completed, how many cycles it's bending. As like the human being, by looking at the date of birth, we are saying that, okay, he has completed this month, 30 years is completed, okay, fine. Okay, and we expect he has to live for 100 years, so 70 years bending, kind of. So that is called the real management. Okay, how much healthy the person when he is at the 30 years of age, and what are the drawbacks he is having in the health, and with this drawback, how you can able to propel the remaining part. That is called the real management. For an example, you work in some engineering college or in the schools. Okay, we talk about the management. What the management people will do? We say that they manage everything. Okay, they manage the faculty, they manage the students, they manage the parents. Okay, whenever they are asking something, they give some, they manage the peoples. Managing the peoples are called as a management. They are the owner of the entire institute and they manage. The same thing here, the battery management means, so battery is managed. Who is going to manage? Whether the battery is managed by himself? No. We need to develop a system. Okay, we need to develop a system. That system is going to manage the battery. And you can ask a question, so why I need to manage the battery? Because battery can be put to death in any of the 2 ways. By doing the 2 ways, the battery can be put into death. What are the 2 ways? The way number 1 is when you overcharge your battery. When you overcharge your battery. Second one, when over discharging the battery. These are the 2 basic. Okay. In addition to that, there are so many other methods, other consequences also there. That is the failure of anode material, failure of cathode material, and the inability of the electrolyte to involved in the chemical reactions, and the failure of the separator, which we normally call as a salt separator, and the failure of the entire encapsulation, and failure of one cell that makes some impact on the nearby cells. Even in your house, UPS battery, you just open and see the UPS battery, and then you can come to conclusion that how many cells are literally working and how many cells are overloaded. How to monitor this one? Okay, every month we have to check what is the status level of the battery. We have to check what is the status level of the battery. Okay, that is because when a human, something happens in the stomach, when they approach the doctor, what the doctor will do, they will scan the stomach and they will say that there is some kind of lump is there. Similarly, our eyes are the scanning device for the battery. By looking at the battery, we have to experience that what are the cells, not just measuring only with a multimeter. Your multimeter reading, for example, For example, if your multimeter reading, you say that a 12-volt battery, suddenly it measures only 2 volt, don't come to conclusion that the battery is faulted. The battery is not working, because we don't know a 12-volt battery, when it is showing a 2 volts, we don't know what is the work the battery is undergoing to give a 2 volt. It may be in the discharging stage, or it may be overloaded by the different load conditions. So that way. So we want to keep on monitoring the battery. So that's what this FDP speaks about on the mRuby. mRuby. What is a mRuby? mRuby is a type of a programming segment. Okay, it's a lightweight segment. Why we want to use a lightweight segment? So this lightweight segment can be easily embedded into the battery. So in order to monitor the battery and condition the battery. Later in 1881, the design of the battery was improved. Even you see, even if you give a question, okay, to the students to design a battery for their house, okay, you come and tell me how many students are appropriately designing the battery. Okay, so they will capture the loads, and based upon the load, they will make only a numeric calculations based on Ohm's law. That is totally wrong. We have to assess the n number of parameters. When we talk about Thomas Parker, so he has made the tramways in London in 1884, and this is the first production electric car. You see the year, okay, 1884. And then we talk about the first electric car, EV. Okay, it's an electric car in Germany was built in 1888. And also the first electric car in the United States in 1890. Okay, so you can able to see all these things are greater than 100 years, are greater than 150 years old. Okay, even you take these kind of vehicles, you can able to see it consisting of a battery is connected to the motor, and that motor is connected to the transmission of 4 wheels, and then it's moving. The same principle only. Even now you are using a Tesla car, it uses the same principle. No difference. Principle of operation is same. But we talk about EV. And then we talk about this golden age of electrical vehicles. Okay, so was between the 1890s to 1900s. Okay, at that time, and even the 1896, the people were using about the exchangeable battery service. That is, when the battery is drained or discharged, what they will do, they will take the battery and they will go to the company, okay, so which we normally call as a Hatford Electric, some kind of company in the US. So they will give the battery and they replace the battery, and then they will take the another completely fully charged battery, and they will keep the replacement of battery. So this technique only, even now the people are doing the research, they call that as a battery swapping technology. Battery swapping means just you take the charged battery and then you keep the discharged battery and keep the charged battery. But it was first proposed in the year of 1896. Okay, you see that is also greater than 100 years. Same technology only we are using even in the Ola Auto in Chennai. So where we are speaking about exchangeable battery service. That is not at all a new technology. But the problems are unlimited. I will tell you the problem statement number 3 in the battery swapping technology. What is the first problem in the battery swapping technology? So a person, they will keep the old battery and they will take the new battery. That's a problem statement number 1. Okay, they will keep a old battery, they will take a new battery. Second one, when the customers are more, for an example, today, some kind of 50 auto drivers, they're keeping the battery at a time. So what will happen? It will experience the grid pressure. Okay, grid pressure is very important concept of the electrical technology. That is, you are pressurizing the grid. You are pressurizing the input power supply to feed all the peoples. For an example, you are taking some 2 peoples to your house for a dinner. So your mother will be happy, okay, because they want to prepare for only 2 members. Okay, for an example, suddenly you are bringing some 50 members to your house. What will happen? That will pressurize your mother. Okay, so she cannot prepare for all the 50 people suddenly. I'm telling suddenly they cannot prepare for all the 50 peoples. That is called the pressurizing. Same way, whenever you're giving some 50 auto drivers are keeping the 50 battery, and that will call as the grid pressure. So once the grid pressure is exerted, what will happen? That will keep on damage the battery as well. Okay, so we cannot say that the grid is doing their work. No, in addition to doing their work, they pressurize the loads as well. So that pressurize, what will happen? That will call as an unbalance in the battery, and a cycle changes in the battery, and some kind of the battery will be get repaired, and the battery will lose their life before their completion of their life cycle. Okay, so this is the thing. That's a third problem statement. Okay. And here let us talk about on the electrical vehicles. Okay, it was given up to 1912. The people are start using these electric cars, and we can able to say that the sales of the electric cars were very much been peak up to 1910s. Okay, so this is called as one of the advertisement for the electric vehicle. So which is be a 35 HP electric vehicle, and it was sold for $2,750. Okay, $2,750, because we cannot able to convert into rupees, because it was in the year of 1910s. Okay, before our independence, because after independence only we are started the converting the US dollars into Indian rupees. So before the 1910s we cannot able to convert, but we can able to assume that this is a very huge amount for 1910s. Okay, a simple electrical vehicle. Now, how the decline of electrical vehicles comes, the people are started using the petrol or diesel vehicle, okay, because of the invention of the electric starter by Charles Kettering in 1912, okay, as starter, okay. So, because earlier they find the problem with a petrol engine, that is how to start the vehicle, okay. So, because of Charles Kettering, so they made a easy start, like a button start. Okay, so where they can put the key and initiate the starter, and that makes so why we are using the starter? The starter will initiate the engine to operate. Okay, so to the lower portion to higher portion, where the starter moves, that makes the engine to start. And then the Henry Ford, he has brought down the prices of all the gas-powered vehicles, and the production was high. Okay, so the electric vehicles come to an end in 1910s. We can say that came to an end at 1910s. Okay, so that was the 1910. The electric vehicle stopped the production. Okay, so nobody is turned with the electric vehicles, because of the Ford company. They've taken over the market of the normal IC based vehicles, gasoline, and the gas powered vehicles, and that has made the stopping of electric cars. The people can ask the question. So, okay, in 1910, it was the 1910, they stopped the EV. Now, how after 2010s, okay, how the EV is started to increase? Okay, we can say that how this particular range, okay, it started ended in 1910, but after 100 years, how it was went as a peak. Many people will say that, sir, due to the price in the petrol, and due to the prices hike and also the depletion of fossil fuels, everything they will say. But the thing is that what happened, this electrical vehicle to again come into the market after 100 years. That is the reason why we are talking in this FDP as well. 100 years of history, why we want to talk. Okay. So here we can able to see that, the electric vehicle has started in 1830s and ended up with 1910s. Okay. So we can say that it is a Great Depression. Okay. So for the many people who used the electrical vehicle, and they ended in 1910s. After 1910, okay, up to in the year of 1968, okay, the people, they showed some interest. Why can't we change again to electrical vehicle? So they conducted an electrical vehicle race. Okay, they started in the Massachusetts. Okay, it's the eastern part of America. Okay, and then they want to go to the western part of America. Okay, so they started from Boston, and they went to the Michigan and Oklahoma, and then they went to Kentucky, and then finally they reached the California. Okay, so this is the we call as a cross country race. It's just like traveling from Kolkata to Mumbai. Okay, a cross country race. Okay, from the eastern to western part of the country. Okay, so this is the race. Okay, which was combined by one institute and also an industry. Okay, the institute is MIT, Massachusetts Institute of Technology, which is in the Boston, and a Caltech, which is in the California. It's called as a California Tech. So in between the eastern and western region, they kept 53 charging stations. Okay, 53 charging stations in between the two things, and they used the nickel cadmium batteries, and the cost of $122,000, in 2008. Okay, so they made a share between MIT and Caltech, and this has made a great impact to the entire world. How the electric vehicle can able to make a boom up once again, because in 1910 it was closed, and in the 68, it was going to start. You can ask a question, sir, why you're talking about nickel cadmium battery? Because at the time we use a nickel cadmium battery. Now we talk about on the lithium ion battery, and then we talk about on the potassium hydroxide battery, and then we talk about nickel, magnesium, manganese hydrate battery. So these are the top batteries which has been used in the electrical vehicle. So I made a comparative analysis between what are the batteries the electric vehicles are using. Okay, I made a comparison, and based upon the comparison, I will show you that is what is the relative merits and demerits. Okay, in the forthcoming slides. So this is myself when I visited this MIT during my postdoc. I have seen the place at which this cross-country race was started. Okay, and here we all know that because of the decline in the gas and because of the reduction in the energy, okay, the people, they renewed their interest in electric cars, and in the California, they started this clean energy, and they started this California Air Resources Board. Okay, and then they made their interest between the electric powertrain, and then they made a electrical vehicle. So till now, we talked about on the basic history. Now we are going to talk about on the practical vehicles. Okay, in the practical vehicles, in the California, so we talk about the Tesla Motors, they developed the first electrical car we called as a Roadster. It was developed in 2004. After the 4 years of testing, it was delivered to the customers in 2008. So this Roadster was the first legally obtained highway car, okay, so which used the lithium-ion battery cells. Okay, so which can whenever you give one single charge, this vehicle can move up to 320 kilometers. Again, I'm telling you, this calculation is for the USA roads, not for Indian roads. Again, I'm telling this particular thing is for US roads. It's tested for, so that means we have to understand what will be the rating of the battery. Okay, what will be the rating of the battery? Because for one charge, it can able to move up to 320 kilometers for a single charge. Okay, so lithium. I will also show you what is the rating of the battery, because we'll talk about on the rating. So this rating and also the power calculations are needed before we are going to design a BMS. If you are going to design directly a BMS, what will happen? As I already mentioned you measure voltage, you measure current, you measure temperature, and you monitor with a small LCD, and you can say that that's a BMS. Again, I'm telling that is wrong. All the research has to be started from the basic ideology and the basic designs, and starting from a power rating of the vehicle. I will explain you. So now the Mitsubishi vehicle in Japan, it was made by 2009 and delivered to customers in 2010. It was in Japan. And again, one more vehicle, the Chevrolet Volt. No? So they had made an electrical car. Okay, and this was work with a 64 kilometer for a single charge. And then they have made an engine. This vehicle, they also made an engine. This engine can work as a generator. Okay, and this generator will charge the batteries. Even our IC vehicles also works with the same fashion, right? So whenever you're operating your car, okay, whenever you are driving the car, this energy from the engine, okay, which will help us to charge your batteries. Okay, because in your car, the battery will be charged. The battery will be charged based upon your rotating of wheels of your vehicle. Okay, so that's the thing, because we are not in the normal IC vehicle. You take Alto or Creta or else anything, Nissan or whatever it may be. So there the batteries are charged only based upon the movement of vehicle while you are driving in the road. Okay, so we can able to say that this engine will run as a generator, and this generator will help us to charge your battery. So that same option they have used. Okay, so where we can able to understand that it is operated entirely from a battery, and this particular vehicle is consisting of a engine and as well as the motor. Okay, so some vehicles where they completely replace the engine with a motor, but some electric vehicles, they use engine and as well as motor, both the things. That is the reason why few electric vehicles are quite expensive, because they not replace the engine, they used both the engine and as well as the motor. So we want to make a proper comparative analysis. Okay, so now we talk about on the dynamics of electrical vehicles, because when this dynamics, it is something quite common, quite similar to whenever you study about the dynamics of wind energy. Okay, so many people whenever you're going to design the wind energy, we have to calculate the energy equation. So this energy equation will tell you the power calculation of the entire wind plants. Okay, so based upon that only we can able to calculate the wind energy. So that wind energy we normally called as aerodynamics. Here we talk about on the vehicle dynamics. You can ask a question, sir, why I want to study this vehicle dynamics? In all my papers, whatever I published or whatever the papers which I guided for the students, either my scholars or other students who are asking my guidance, in all the papers, I asked the students to include this dynamics in their paper. Okay, so one of my students, is not my scholar, but anyway, he is my student in his masters. Okay, so I guided him to use this dynamics for the typical different vehicles. So he used the school bus, vehicle dynamics. He used the school bus, and later he used the Suraj Masta vehicle, and later he used for the truck. Because you should understand, whenever you take a vehicle dynamics, okay, so the power calculation will come greater than 100 kilowatt. Not we are going to work with the watts, which will go in the kilowatts, 100 kilowatts, 70 kilowatts or 80 kilowatts. That will be the rating of your entire electrical system. We are not going to talk about the mechanical system. We are going to talk only the electrical power systems. So whenever your complete rating is about 80 kilowatt, so you call this motor of 80 kilowatt. Okay, so for the 80 kilowatt, we have to design an electrical power system with a battery such a way that how this battery can power my 80 kilowatt or a 70 kilowatt or 100 kilowatt. Okay, so we want to make a battery. Okay, so I want to feed the battery to charge such a way that how it can able to feed for 80 kilowatt. So I make one small design. So in this design, I also made on maximum a sample calculation. So the calculation will help us you to understand the output is a 70 kilowatt. Okay, so I want to design my system for 70 kilowatt. So now I will explain you how to make a design power rating of an electrical vehicle. This is very interesting, or it is very important before we are going for the battery management system. So if you have any questions, you can post it. Okay, I hope still I'm coming back again and again to the thing. So somebody has raised the hand. Any question?
Sir, your voice is very low, sir.
Low? Is it so? How long?
Very slow, sir. Voice is not hearing.
Now or from the beginning? Hello? So
Yes,
can
sir.
anyone tell me whether my voice?
So yeah, we can able to get, sir.
Sir, it is audible only, sir.
Okay.
Yeah, audible only.
Okay. Okay. So
From
please
first it is audible.
Okay. Because I that is the reason. But that is the reason I keep on check the people with whether your so voice is very slow. Sir, I'm shouting. The people from my nearby house, they are coming and asking whether some quarrel is going on over here. So
Yeah, we are getting clearly, sir.
okay, it's my usual way of taking my class. So fine. Okay, so I hope I can go with a bit louder. So now we are going to talk about on the vehicle dynamics. So we all know that, as a wind energy, this electrical vehicle, initially it will work basically on the kinetic energy, not on the potential energy. Because the kinetic energy, we talk about half into m into v square. The same formula only we will be using when we are calculating the energy of the wind energy. Okay, kinetic energy. So here we want to understand. Okay, let us talk about a car. Okay, you assume that the car is moving in this direction. Okay, in this direction the car is moving. Okay, so normally whenever we are going to make a design, this is called as a floor. The x-axis is going to be the floor, and then we want to make a design not for the straight line. Okay, because our car will not move only on the straight line. It will move even for climb the hills as well. Okay, so even it can be able to climb the hills as well. So the angle we are considering is as a theta, the angle at which the car climbs.
பிரேக்
Sir,
எது
mute
சுத்தமா
mode.
இல்ல அவர் தெரியாம
Sir, mute பண்ணுங்க sir, please sir. Okay, thank you. So here we can say that, let me go across here. So this is a theta, the angle at which the car climbs the hill. Okay, so we want to make use of this particular thing. So here, this is the central part we normally call as a gravity of the vehicle, and M is called as the mass, that's the total weight of the vehicle, and G is called as a gravity. And we can say that, two important things. One is called as a sin theta, and one is called as a cos theta. And the combination of these two levels we call as a mg. So this is called as a central part of the vehicle. We have to make use of the mg sin theta, mg cos theta, and mg. So these three factors. Now we are going to talk about on some kind of forces. Okay, so when the car is going in this particular direction, we can say that there are three forces that will act opposite to the direction of the vehicle. Okay, so let us talk about V is called as a speed. Okay, so here in the vehicle dynamics we speak V is called as the speed. Okay, normally we use N. Okay, but in the vehicle dynamics we use V. So where V refers to the velocity of the vehicle. So when the car is moving in this direction, the opposite direction, this is the opposite force number one. We normally call it as a VW. W stands for window. Okay, window, the force that is acting towards on the window. And the second opposite force is mgCRR cos theta. So M stands for mass, G stands for gravity, and then we can talk about cos theta. This CRR is the constant. We normally call it as a rolling resistance. So rolling resistance means what is the rolling resistance of your tire? That is called as a CRR. Okay. That's called as a CRR. Okay, that is the second force that is acting in the opposite to the vehicle. The third force we normally call this is derived from the half mv square. So half is there. Here the mass is given by rho into A into CD, where rho refers to the air density, A is the area of cross section, and CD is called as another constant, as like CRR, we normally call as a diffraction constant. Okay. And then we talk about on the two velocity. One velocity is going this direction, one velocity is in this direction. So V minus VW the whole square. That is the V square. So the kinetic energy formula, we are using this over here. And the direction towards where the car is moving, this direction travels in the direction of the car. We normally call as a FT, where T stands for traction force. Okay, so one is on the traction force, whereas the remaining forces act in the opposite to the direction of the vehicle. So now you understood what are the only using this parameters you can design an electrical vehicle. We can design an electrical vehicle through this particular thing. Why we want to know all these things only? Then only you can able to understand what is the capacity of the battery you are working with. Normally, whenever you are working for the EV batteries, don't work with a 12-volt 100 Ah battery. That's a UPS battery or a car battery. Okay, that's a normal batteries. Okay. UPS battery or a normal battery which is useful for the residential purposes. Car battery or the lorry battery is totally different. Okay, because it is going to power the motor, which is about more than 50 kilowatt rating. Okay, so we have to understand about what is the nature of the vehicle, nature of the battery, because that battery is very, very important for powering my machine. Okay, so here we can able to understand the force balance equation of the electrical vehicle is given by M alpha. Okay, so M is the mass, alpha is the constant factor, is equal to FT, that's a traction force, minus what is the rotating force, a reverse force. We call as a resistive force. So as I already mentioned you, the three forces are acting in the opposite side. Okay, what are the three forces acting in the opposite side? First force is mgCRR cos theta, acting opposite to the direction of the movement of the vehicle. Second force is the kinetic energy force, and the third force will be mg sin theta. So three forces are acting in the opposite to the direction of the vehicle. So we call these forces are the resistive forces. This is the movement of the car. This is the resistive of the force. So now I want to talk about on the traction force. The FT is called the traction force, or it is also called the propulsion force. So FT will be equal to M alpha plus summation of FR. So M alpha plus summation of FR, the three forces that is acting. So M alpha plus the three. So now you can able to understand this FT is called as the force that is needed for the propulsion. that is needed for the proposal. So any people that are attending who are students of final year or the research scholars who need some jobs in the EV industry, we want to refresh this particular thing. Whenever they ask you about any questions about the power management of the electrical vehicle, and if you are very much interested to derive these equations and to show what will be the rating, that will be a very interesting one. Because we always approach, that's what my professor used to tell me, whenever you are writing a paper, if your paper has some kind of equations, normally it will be get accepted. Okay, so for the electric vehicle is concerned, I will also show some of the equations that governs the equivalent circuit of a battery. I will show, because in our Thursday session, I will explain you the equations represents the battery. So all these equations are very important. So we can say that this is called as my force. Now I want to calculate the power. So the power formula is given by the force into speed. Okay, the power. Here we talk about both the things that are mechanical in nature. So one is called as a force, one is called as a speed. So what is the force needed? What is the force needed to make the vehicle to move at a particular speed? So this combination is given by the force, power. So what I do, I want to multiply this Ft with the speed V. So what will happen? M alpha V, mg CRR cos theta V, half into this into V. I'm including a V, and m sin theta into V. So the formula which I marked in the red color, this formula we have to use to find out the power rating of your electrical vehicle. So normally, whenever I'm teaching the subjects like electrical vehicle, okay, I usually give the values. I usually give the values of mass. I usually give the value of speed, and the theta values will be given. So the people, they have to substitute this particular formula, and they have to tell me what is the power rating of the vehicle they design. So we can able to understand with the equation number 1, equation number 2, we arrive the equation number 3. This equation number 3 is enough. Okay, this equation number 3 is enough for designing your entire EV, power rating of your EV. So now I'm going to explain you a model calculation for this one. So let me come back to the thing. So if you have any questions, I can able to say some questions over here. How is M alpha? What is M alpha? I will tell you, sir. For this, I have given you one model calculation over here. So that will help you to understand about the individual factors. So I will tell you. So you can able to understand that this is the formula what we have discussed. Okay. So for an example, I'm giving the mass, that is the weight of the vehicle. That is the mass of the entire vehicle is given by 1000 kg. Okay, so it depends upon the vehicle, it may vary. For an example, you are taking a very small vehicle or a big vehicle. So based upon the mass, it is the vehicle. Speed, initial speed, I'm talking about what is the speed, my requirement of the speed. Okay, I normally expect about 100 km per hour. So only these two are the available values. And sir asked about the mass I have given and alpha value. Alpha value is the initial deformation constant. So initially, what will be your nature of the vehicle? It's in a standstill condition. So whether you are going to start your problem by such a way that, whenever let us talk about a sinusoidal waveform, whether you want to take the phase at 0, or else you want to make a phase shift after 30 degree, or whether you want after this 90 degree kind of, So this is called as the alpha. So we want to start from the initial thing. So the alpha is equal to 0. If you want to make something like, some initial variation, and after some angle, you want to start your calculations, you can make it as a thing. But anyway, whenever you're going to use alpha as a 0, we can able to see that the first quantity will become 0. Okay, because mass is 1000 and alpha is 0, we can say that, it is equal to 0. Okay. For an example, if you're going to use alpha is equal to 10 degree or alpha is equal to 5 degrees. So based upon that, the variation, whether you're going to start or whether you're going to start quite lagging the design. And second one, we talk about on the M. So what is the M? Mass is 1000, gravity is 9.81, and the wheel rolling resistance I've taken from the data sheet, that is CRR is equal to 0.02. 0.02. Okay, and then we are going to talk about on the cos theta. Okay, so cos theta. So I'm going to take the theta is equal to 0. That means what is theta? Okay, you are going to understand this is going to as a theta. For an example, if you want to design the vehicle with some angle, with the tire is there, and there's a vehicle. If you want to understand some angle, you can give the theta value. Or else initially you want to design for the normal plain roads, you give the theta is equal to 0. So cos theta, cos 0 is equal to 1. So it's 1 plus, okay, half is given as a 0.5. Rho is called as the air density. We know air density is equal to 1.2 kg per meter cube. So rho, okay. And then I want to talk about on the area. Okay, so here the area is going to be, okay, 1000. Sorry, here the area, that is the initial front area, 2 meters square. Now, what is the area? So the area is the front end area. It's a 2 meters square. Okay, it depends upon the vehicle. So A is a 2, and CD is called as the diffraction constant. I'm going to take it as a 0.5. Okay, so 0.5. And here I want to take it as a V minus VW. Okay, so let us talk about here the VW, the window speed, the opponent speed, I don't know. So I'm going to make an initial speed as 100 km per hour. Okay, so let us talk about the 100 km per hour. I want to convert to meters per second. So multiplied by 5 by 18. Okay, so how much you will be getting? You'll be getting the value as 27.7. Okay, you get the value as 27.7. That is multiplying 100 into 5 by 18. That is converting your kilometer per hour to meters per second. So you get as a V minus V cube is equal to 28 square. And here we talk about mg. What is mg? M is the mass, gravity is the thing, sine theta. So theta is 0. So sine 0 is 0. So this factor is also becomes 0. And the bracket we are having on V value because I want to multiply the voltage for the each and every parameter. So multiplied by V. So by solving this expression, we'll be getting the answer as 31 kilowatt. 31 kilowatt. So now you want to design. So now the design ends that it is about 31 kilowatt. Okay. So for the vehicle of mass 1000 kg and the speed requirement of 100 kilometer per hour, 100 kilometer per hour. Okay. And then you want to make. Okay, and then you want to make things, So if you want to make a 100 kilometer per hour for these kind of values, okay, my answer is going to 31 kilowatt. So this is my design. In addition to that, you're having the one more choice that you want to accelerate this speed from 0 to 100 kilometer per hour, initial acceleration in 10 seconds. So you want to calculate this initial option. Okay, if you don't need this option, you leave it. No need. You complete the calculation only up to 31 kilowatt. But normally we expect that this 0 to 100 kilometer has to be accelerated in 10 seconds. So initial in the initial speed, because the initial excitation. So when it reaches a saturation, we can able to see the speed at what it goes. Okay, so we can able to understand that So here we go. That is the formula will be given by mass into this 10 seconds. We are going to convert into the meter per second. So it will be equal to 2.8 as like this 100 is converted as a 28. Here it will be a 2.7 and then 28 divided by 2. So I will be getting as a 14. So this is the mass and this is a 10 and this is a 100. So all these three factors are combined. I will be getting the value as 38 kilowatt because you need a additional option. The option is you want to accelerate your vehicle 0 to 100 kilometer per hour in 10 seconds. In 10 seconds. So now what we are going to do, this is the actual calculation, 31 plus 38. You will get the total maximum power requirement of the electrical vehicle based upon this vehicle dynamics is going to be nearly 70 kilowatt. That's a 69 kilowatt. This is the power calculation. So now you can able to understand that, there's a 70 kilowatt vehicle. For this, I want to make a choice of a motor. Because this is my total for the weight of this, because I no need to want to concentrate only on the electrical parameters, but also on the force that is exerting across my vehicle. Okay, so the force may be coming from this side. I want to concentrate on the three major forces and the rolling resistance and the deformation constant, and everything will be connected and made it as a mathematical modeling, and finally we get the maximum power. So we should understand that what will be the rating of the battery, to meet this needs. That is our overall objective. Okay, for the 12-volt battery, measuring the voltage, measuring the thing, that is very simple. But how far we are going to do that one? So for this, we have made one consultancy for an industry in Bangalore. So what we have made a design of a 30 kilowatt system. a fast charger. Okay, so hopefully I will share our findings. So that consultancy was completed for an industry. So we developed a fast charger with a dual active bridge converter in the closed loop configuration. So those results I will share with you in my Thursday session. So where you can able to get some idea that how the fast charging and how this battery management helped me in order to, because of the dual active bridge converter, it is not an easy thing. So I'm going to control the two different converters. So we want to control the two different converters as well. So how to make a range calculations for a battery? Okay, range calculation means, for an example, this is the rating given for a battery. So battery is known for the energy capacity, not for power capacity. What is meant by energy and power? So we know power is equal to voltage into current. Energy is equal to power into time. So power is given by watts, time is given by hours. So I can say that this is a power, kilowatt and hour. So it's the energy rating. Okay, so we can able to say that that's the reason in your battery we are going to measure 12 volt 100 Ah battery. So then what will be the energy rating? So V into A, that is called as your watts, multiplied by hour, H, hour rating. So we are able to understand the 40 kWh. So what is the kWh? kWh is equal to 1 units. Okay, so you should understand that 1 unit of electricity is equal to 1 kWh. So I can say that 40 units of a battery. So I can say that this 20 kilowatt, I'm using the energy of 20 kilowatt from the battery to run the vehicle when I was running the vehicle at 50 kilometer per hour. When I'm running the vehicle at the 50 kilometer per hour, my consumption is 20 kilowatt. So I can able to understand that the battery can able to release the 20 kilowatt power for 2 hours. Okay. For an example, if I'm going to make use of that in the 20 kilowatt, because I'm having the 40 kilowatt hour. So 40 kilowatt hour is the energy capacity of the battery. Out of the 40 kWh energy capacity of the battery, the first 20 kWh I'm going to travel for the 50 kilometer. The next 20 kW I'm using for the next 50 kilometer. So what is the range calculation? So I'm going to travel the 50 kilometer, okay, into 2 spells, into 2 hours. Okay, so I can able to travel 100 kilometer per charge. So if you are charging the 40 kilowatt hour of a battery, you can travel for 100 kilometers. How? The 100 kilometers, 50 kilometers, you are using the 20 kW, and another 20 kW is using for another 50 kilometers. So totally you will be using the 100 kilometers by giving the one charge. This is the range calculation, how we want to maintain the battery. But this is the theoretical calculations. Normally, here whatever we are doing is a theoretical calculation, but practically it is influenced by various factors. That is the reason we want the battery management systems. Now we got a clear problem statement of battery management system. So in this battery management system, a clear overview is how far we need a battery. What are the items to be managed? Okay, how far we take this battery for working with the different case. Okay. Next, when we talk about on the economical calculation, let us take a 1 liter of petrol. Okay, now it is 110 rupees. So we talk about on the 101 per liter. Let us take about a diesel. So we can able to understand if you want to travel for let us say that your vehicle gives a mileage of 15 kilometer per liter. So what is happening in the conventional IC based vehicle, in order to travel 1 kilometer, you are spending 6.77 rupees. Literally 7 rupees you are using for traveling 1 kilometer. Okay. For an example, if your college is 10 kilometer from your house, you are taking your vehicle, okay, 10 kilometers. So how much? While going, you are spending 70 rupees. While coming, you are spending 70 rupees. Totally 140 rupees. Okay. While you're going for the electrical vehicle, for the same amount, I'm going to pay the electricity bill. I'm not going to take the petrol or diesel. So 1 unit is equal to 8 rupees. Okay. Let us say that, for the same 120 kilometer, I can able to manage for the 320 rupees for 120 kilometer. So I can be able to say that if you want to travel for 1 kilometer, you are spending nearly 3 rupees. So half of the rupees only you are spending while you're going for the electrical vehicle. So these are some of the survey what we have done to show you about for the electrical vehicles, the different electrical vehicle. So what are the things which we have surveyed? These are the popular EVs. So I made a survey with only on the power train. Okay. So so if you have any questions, you can able to post it, because now the time is 7:30. Okay. After this comparative analysis, I can stop my session, and if there is any questions, we can able to discuss, and we again continue on Thursday. Okay. So let us talk about on the Nissan Leaf, because since we have started 10 minutes late, I will cope up this 10 minutes up to 7:40. Okay. So this is my commitment. Okay. So far this one and a half hour session. Okay. So let us talk about the Nissan Leaf. Here, the power train. What is the power train? Power train is a common word. Train is not used for the Nilgiri Express or Charan Express. That is not a train. Train is a normal English word which is used to where the number of blocks connected together, that is called train. But we colloquially using a train is a transport. So train means combination of more components. So here in the electrical vehicle, we are having the power train. Power train means which are associated with the electrical technology. It's called power train. Where the electric current passes, that is called the power train. So in the power train, we can able to understand the initially it will be having the battery. Okay. And we talk about on the electric motor is connected to the battery. And then the transmission from the electric motor to the wheels, I want to transmit. That's called transmission. And I want to concentrate. These are the parameters, the range, and also the plug-in charging. So there are various models are available. Okay. So which we comes across in the model MY. It's for the Nissan Leaf model and MY 2013, MY. So these are the models. Okay. So here our concern is about on the survey of battery. Okay. So here the battery is about 24 kWh. Or 30 kilo kWh. Okay. That means, in a house, how much we are using? So in our house, we are using 12 volt, 100 AH battery means, okay. So how much we are going to use? Let us talk about on the both the things. Let us talk about on the 12 volt and 100 AH battery. So let us talk about, let us say that divided by 1000. So I can say that in our house, we are just using 1.2 kWh. Or else, similarly, we are using just 1 kWh battery in our house. That is 12 volt into 100 AH battery. So which will be called as a 1200 whatever divided by 1000. So we'll be getting as a 1.2 kWh. You just compare this 1.2 kWh with the 30 kWh of the battery which were used in the EV vehicles. That is the reason whenever you are working with a battery management system for a electrical vehicle, don't use this normal batteries of 1.2 or 3 kWh and showing the voltage and current. We have to use at least greater than 20 kWh or 30 kWh. Then only we can be able to assess the battery performance. So how far the battery perform? Because these 1.2 kWh is used for only for powering the tiny loads like two blades and 3 fans, okay, and 1 mixie kind of. That depends upon the load what you're connected with the UPS. Okay, so we can speak about the battery which we are using in our house is structurally about 1 kWh or 1.5 kWh at the maximum, provided if you're using a 120 AH battery in your house. But in the electrical vehicle, it is about 24 kWh or 30 kWh in the standard vehicles. Okay, and also we want to concern about the motor what we are using. Okay, in the Nissan Leaf, we are using a synchronous motor, and this motor is about 80 kilowatt. You see about the rating. Why it is 80 kilowatt? Based upon a design, what we made over here. As like this design, they made, and then they found that, the power rating is about 80 kilowatt. Okay, 80 kilowatt, 280 Newton meter, and 110 HP synchronous motor. Okay, and again, the data sheets, we have to also concern about the plug-in charging. So the plug-in charging, so this particular vehicle can able to operate with 240 AC or 480 volt DC. So which is having the inlet and adapters with the help of the AC sockets for US and Indian voltage rating, we can able to make a charge. So a 3.36 kilowatt or 6.6 kilowatt, the charging potential to charge my battery of 30 kWh, and this battery is helpful for powering my synchronous motor through an inverter. And next vehicle we take an analysis is called as a Ford Focus. So in this Ford Focus, we can able to see the electric motor is a 107 kW synchronous motor, and the battery is again 33 kWh, again the lithium ion battery. So we can able to see that for one charge, it can able to run for 185 kilometer, and the plug-in charging rating So even I wrote one paper that also published in IEEE, so where we made an analysis only on the shape and the type of a charger. Okay, shape and type of the charger inlets for the different cars we have made. That also I will share with you to the participants. And BMW i3, you can see, as I already mentioned you, the standardized vehicles, okay, they will be using both. One engine also they will be using, and motor also they will be using. They use both engine as well as the motor. And again, the battery, we can able to see that, 60 i3 60 Ah and i3 94 Ah. Okay, so which will be called as my 22 kWh or 33 kWh. We concentrate on the energy rating. We can say that the current potential is 60 or 94 Ah. And the electrical range for the different models and the plug-in charging is a combo of AC and as well as the DC 7.4 kilowatt onboard charger. I will also explain what is the difference between the onboard charger and the offboard charger. Okay, and what is meant by fast charging, what is meant by slow charging. So those things also we'll be discussing. Let us talk about on the Chevrolet. In the Chevrolet, we will be having both engine as well as the motor. So here we talk about it makes use of the permanent magnet motor while it is traveling, and the regenerative action will work as a generator as well. We call as a motor generator, forward and the reverse direction. And again, the battery, we talk about on the battery is about 16 kWh, 17 kWh, and the second generation 18 kWh. And the range and also the plug-in charging with the various voltage and the current ratings, sockets, Chevrolet. Let us talk about on the Tesla powertrain. So here we can able to understand. So whenever I'm teaching the three-phase induction motor, I will show this particular slide as a first slide, and I will tell the students that in the Tesla, yes, we are using a three-phase AC induction motor. Okay, so in the earlier vehicle, we talk about they are using the permanent magnet machines, they are using the synchronous motors, and here in this particular Tesla, they are using the three-phase AC induction motor. And the batteries again of the different values of 60, 70, 85 kWh, and the electric range and the plug-in charging with the various potential. And again, I'm telling you what is the difference between the onboard charger, outboard charger, and also fast charger and the slow charger, AC charging. That comparison I will tell later. Mitsubishi MIEV is again we made a comparison of electric motor, and the battery is again lithium ion battery and the motor is permanent magnet motor. So here we go, I just skip this particular thing. So as a research, so finally I complete this slide and then we can end up the today's session. What is our objectives? What is your takeaway message of the today's session? Okay. What is the objectives of the hybrid electric vehicles? What is the objective? Okay. What are the research problems? First one is we want to maximize the fuel economy. Okay. Fuel economy means it is a charging, because even for the charger, you'll be giving some set of inputs, how to maximize the fuel economy. And second objective is how to minimize the emissions. Okay. We say that we can able to power the battery by with help of the renewable energy, but typically it is not possible. It's not. We are not doing that one. And then how to minimize the cost for the propulsion system, cost of the battery and the motor set to make it affordable. Then only the common people also can able to buy the electrical vehicle. The fourth problem statement of the today is how to reduce the cost of the overall electrical vehicle. Because as I said, that the first problem statement, you compare with the last problem statement. The first problem statement, I said that how to make the electrical vehicle suitable for the Indian roads. Second problem statement is how to make the electrical vehicle suit as a affordable cost that is applicable even for the middle class people to buy this electrical vehicle. Okay, and how to maintain this performance with a reasonable cost, and how to reduce the weight of the conventional vehicle, because you can able to understand the battery is about, even you see in your house, you're using 100 Ah battery. You see the weight of the battery of your UPS, 100 Ah or 120 Ah battery weight. Similarly, that is a 1.2 kWh. You just to see the weight of the battery, what you're using in the electrical vehicle. Okay. One more thing I will tell you, whenever the normal car, okay, if you are driving in the road, suddenly some thing happens. So you want to stop the car and you can able to make the tow. You can connect the tow for the car. Okay, you can pull the car by towing, but that process is not possible with the electrical vehicle. So the next class on Thursday, I will ask these answers for the participants. Okay, why you should not tow the electrical vehicle? If suddenly stops in the middle of the road, okay, you see, this is the thing what every drivers need to know. Okay, if the normal car, if it is suddenly happens, you can even some accident or something, some drain happens, So what we'll do, we'll just pull the vehicle with a tow, but you cannot tow the vehicle which is an electrical vehicle. What is the answer? We can meet on the Thursday class. Okay, so that's all for the today session. So if you have any queries, okay, we can able to discuss now.
Participants, if anyone is having any questionnaires, you can unmute and raise your questions.
Or else even you can type in the chat box if you are unable to type to ask the questions. Because sir asked me to come. Yes, sir.
Sir, regarding the disposal of the battery after the lifetime, is there any guidelines?
So actually, even for the DST, they asked this call for proposals many a times. Okay, so many a times, so, but the safe disposal, even when you visit the IIT Madras, there is one startup. It's now they shifted to Hyderabad. The startup name is CBEEV. The CBEEV, Center for Battery Energy and Electrical Vehicles. So they made some kind of works, so such a way that we can able to understand the safe disposal of batteries. Okay, how we can able to collect the materials, how to reuse the materials. Okay, so safe disposal means we need a separate industries. Okay, such a way that when the unused batteries, when we given to the industry, they want to segregate the anode material, cathode material, and using the machine learning or with the help of the AI techniques, they want to assess how much of the material can be reused. Okay, nowadays what's happening, they are throwing the battery or else they are shifting the battery. Only those things are happening. But the thing is that the safe disposal of battery, it's a need of the hour, and some industries we need such a way that we can give those unused batteries, because it's also quite dangerous as well. Okay, but many a times we are having a very good battery, but we cannot be able to. We are throwing the battery. Even I used to say, whenever the AC is not working, we just replace the AC. But we don't know what's the problem happened to our AC and how to rectify the AC like that. That's a problem.
Yes. Thank you, sir.
Hello, sir.
Yes, sir.
I have just two doubts in my mind. I want to know that is there battery voltage and motor voltage are same? And
No.
in electric vehicle?
No.
Okay. And
No.
second one is there any importance of gear ratio for the calculation of torque? Because in your dynamic slide you calculated power, but there is no light on the torque calculations there.
Yes. So the torque calculation, what the torque is, we want some initial energy. Initial energy is called as a torque. So normally this battery, we want actually this is the design of the battery where it can able to provide the initial current. So that is enough for creating the initial torque. Okay. So once the initial torque is exerted, then we can able to pick up the speed of the vehicle. So that is normally available even in the IC vehicle also. Okay, so where which we normally called as a pulling torque and the holding torque and kind of. So where with the initial ignition, that is enough for creating the initial torque. So we don't want the torque to be sustained throughout the operation.
I think I saw in many of the vehicle catalog, there is a gear ratio they maintain in the EV catalog also.
Yes. Gear ratio they maintain because that is for the safety, because that's all the standards, sir. So normally, so whenever they are making any data sheet,
in EV calculation, na?
Yes.
Okay, and
we can.
Again, I have one doubt that in your dynamic slide, you calculated total power. That is the power of motor, not a battery.
No, it's a overall power needed for the system. So we can able to say that the complete load item is going to be the motor. So for an example, if my calculation is 69 kilowatt, the 69
Yeah.
kilowatt will be the rating of my motor.
Okay. And as per we decide
Then,
the rating of battery.
yes, yeah. Then I want to design a battery such a way that which battery is ready enough to power my motor.
Okay. Fine.
That is the thing.
Thank you, sir. Okay.
Thank you. So if there is no any more queries, we'll again meet on Thursday. Thank you so much. In the Thursday, we'll be discussing
Thank you,
on
sir.
machine.
Session was really informative and more enough to learn, sir. Thank you.
Thank you, sir. Thank you.
Now the next session speaker is waiting in the meet, and now I would like to call upon Mr. Prithviraj sir to give the brief note about our session 4 speaker.
Good evening all, myself Prithviraj. We are pleased to welcome Ms. Prerna Ajmani, Assistant Professor at Vivekananda Institute of Professional Studies, Delhi, as a resource person for session 4. Ms. Ajmani brings with her a strong academic background. She holds a Bachelor of Science in Physics from Miranda House, Delhi University, a Master's in Computer Application from PDM College of Engineering, Bagadur, and an MTech in Computer Science of Engineering from Delhi Technological University. With a passion for research and innovation, Ms. Ajmani has published over 25 papers in reputed international journals and conferences. Her contribution to technological innovation such as IoT-based vaccine box, LoRa, ad hoc network-based outdoor wireless communication system, and many other patents. Her achievements and dedication to the field make her an invaluable speaker for today's session. Now, I warmly welcome our resource person, Ms. Prerna Ajmani, to begin the session on integrating mRuby with BMS for real-time battery monitoring. Welcome, ma'am.
Good evening,
Thank you.
everyone, and thank you so much for this wonderful, welcome. And I'm really thankful to Dr. Dhyagarajan for giving me this opportunity. I hope I'm audible to the audience,
Yeah, ma'am.
and
You're audible.
I'm really hoping this session will bring very meaningful context to the audience. So with this, I'm sharing my slides.
Yeah, ma'am. On behalf of Rice College of Engineering and Technology, I welcome you to take over this session now. Thank you.
Thank you, sir. Thank you so much. And it is a wonderful team who is organizing this session. I've joined 10-15 minutes back, and I could see a well coordination among all of you, and you all are putting a lot of efforts for this FDP on, and you want, you're putting a lot of efforts that everybody should get, good, meaningful resources after doing this FDP.
Thank you, ma'am. Thank you so much.
Here we are. I hope my slides are visible.
Yeah, ma'am.
Okay, so my topic is integrating mRuby with battery management system for real-time battery monitoring. So first of all, a little intro I would like to give for myself. So I'm Prerna Ajmani, and I'm presently teaching in Vivekananda Institute of Professional Studies. Here's my LinkedIn profile. You can always visit this LinkedIn profile. I have worked collaboratively with many people across India as well as in international domains. And my PhD is about to be completed. I've submitted my PhD and it will be completed very soon with all your blessings. So I would like to share one thing, that this is one of my book which is listed in Harvard. This book is on wireless communication technology, and I'm very much interested in electric vehicles. I'm exploring my phases into electric vehicles with mRuby as my one of my domain where I'm working in mRuby. So I think I would be able to deliver the session nicely to all of you. So these are my credentials. My LinkedIn is there. You can always connect with me over my mail, or you can have my phone number from Dhyagarajan sir, and we can connect and collaborate for various research projects. Moving on to further, I would like to first make a disclaimer. that this PPT contains text, images from various resources, and all my due credits to each resource from wherever I have taken the information. However, I'm unable to cite each resource explicitly. So, moving on to further. So, today, before I start, I know that everyone is talking about battery management system. All entire FDP is based on battery management system. So, a simple question: what is battery? How would you describe that? What is battery? Anyone could, like, it is on the screen also. I want an interaction from the audience.
Battery storage of electrical charges.
Yes. So, with EV, thank you, sir. So battery is basically, it stores the chemical energy and converts it into electrical energy. With the EV coming up in the market and renewable energy resources search in the market, because we are in a verge of already a lot of resources are at the verge of depletion, so we are actually looking for renewable resources. So battery is one of the crucial component nowadays, right? So in electric vehicles we use batteries to charge our vehicle and to give the power to our vehicle. Even in the phones and laptops we are using the battery, right? So battery, you can consider it as a tank of a water, and the cells you can consider as a cup of a water, and modules as jugs, and pack as a big tank. Because when I talk about EV, electric vehicles, so we will be more talking about pack of batteries, right? Okay. So there are various components of batteries, like you all are aware, I'm sure, but just giving you a quick recap. So battery components are anode, cathode, electrolyte, and separator. When anode is, you can assume anode as a start of the city. Suppose there is a road system. Anode is a start of a city from which the electrons releases. Cathode is a destination which receives the electrons. Electrolyte is a road, and separator is a barrier to prevent the short circuit. So it is just a common way to explain, in a layman language, that what components a battery has. Now I am more concerned about the pack hierarchy or a pack of a battery structure, because in EV I have a pack of pack of battery. So you can see a picture over here where there is a cell, a module, a pack, and a system. Okay. So pack, multiple packs constitute a system. So this is a EV batteries, and Tesla EV has 7,000 plus cells in a pack. So they have a lot of cells. What is a cell? We had already discussed. So cell is, I mean, battery. Okay. And module is a combination of cell, and pack is bigger than that, and a system is a collection of packs, right? So I can say that one cell is a brick. Many bricks makes wall, that is module, and many walls make the pack, that is your combination of lot of modules, right? Now cells are combined in series or in parallel. Okay, we should know this structure before we start with BMS, battery management system. We should be knowing that how our battery works, what is the battery, how it is working. Okay, how can I manage a system when I don't know about the system? So just for a quick recap, so over here a pack you can see, or in the pack, cells are combined in series, in series or in parallel. Okay, they can give a cells combination can give you more voltage or can give you more capacity. Now what do you mean by more voltage? How can you differentiate between a capacity and a voltage? Please, anyone from audience? Anyone from the audience? I hope I'm not making you sleep. Anyone from the audience? What do you think? What is the difference between a voltage and a capacity? Am I audible?
Yeah, ma'am, audible, ma'am.
Okay. So I think the audience is, quite tired at this time and they are just not in a mood to interact. So, can anyone tell me the difference between voltage and the capacity? That's a very basic thing. Okay. So voltage is basically tells you that, what kind of a device that battery can power. Okay. Right. Right. For example, I have a charger which says 25 volt. Okay. So it can power my phone. Okay. With that voltage is a current, which tells what kind of a device a battery can power. And capacity tells you how long it will run. If I
It
say
will,
my battery is, yes, please.
how long it can able to withstand the capacity.
Yes, sir.
Okay.
Right. So if I say that my battery is having a 80%, power, my phone battery is 80%, then capacity that it will, how long it will run. Okay. So that is a capacity. So voltage and capacity, there is a difference between the two, yet both seem similar. Okay. Now, if I just recap, whatever I've said it right now. So, battery, what is a battery? Battery is like a large tank storing the energy. Okay. And cells are the cup of the water inside the big tank. And BMS is a teacher or a brain which is managing the cells. So, battery management system is very, very important, very crucial. We have to manage our batteries, otherwise, there will be disasters. So, BMS, is to be taken care of with coding, which I will be walking you through this coding, and I'll be doing some demo exercises also, where we will be coding in Ruby, okay, mruby. So we will be coding in Ruby for this managing the batteries. So what is BMS? BMS is managing your batteries, right? Now, why you need to manage your battery? There are so many incidents, so many problems. First I walk through that, why we should use BMS. What is a problem? The problem is, if your battery is not managed, right, then your cells, if they're overcharged or overheated, then there is a risk, fire risk, and we cannot take this risk when we talk about electric vehicles, right? It will be a disaster if my, battery is overcharged or overheated at any point of time. Then it can, bring life at risk, and it will be a fire. Okay. So battery management is very, very important. Then over discharging is also causing a problem that need to be checked by BMS, because over discharging will cause the permanent damage. Okay. Then in extreme temperatures, we face extreme temperatures, sometimes extreme hot summer day, or an extreme cold environment in some areas, some parts of the world. So in extreme temperatures, reduce the performances. Over here, BMS plays very important role. If our battery is, powered by this BMS, then what happens? They can, adjust, they can do the setting or do the adjustment to, for batteries to work for a longer time and to work efficiently in extreme temperatures, right? So if there is a unmanaged cells or unmanaged battery, the cell drift apart over the time, and weak cells overcharge while others stay normal. So that brings an imbalance, right? Imagine a Tesla car with 7,000 plus cells. Some of the cells are consuming the whole charging, and the others are not even given the chance to charge themselves. So what happens? All the functions will not work smoothly, and the car will not be able to function smoothly, right? So this is very, very important that we should focus on, battery management system. Okay. So let me talk, a little bit more about the batteries. So we have different types of batteries that are being used in electric car vehicles. There are some lead acid battery, NIMH battery, lithium ion battery, ultra capacitor batteries, right? So there are so many type of batteries that are being used by different vendors. They are experimenting, they are doing, different batteries due to some, some batteries are cheap, some batteries are, lightweight. So because of some battery can provide the extra power to the vehicle, so they are doing, different kind of batteries they are using, in their vehicles. Now, when they are using different type of batteries, we should have one protocol or a one type where we can regulate these batteries, whether the battery is ultra capacitor battery or whether the battery is lithium ion battery. So my battery management system should be efficient enough to handle any type of, any type of battery. Battery management system is not just developed for a single type of battery, right? So that is what is required in today's scenario, that a battery management system should be able to handle, any type of battery that is being used in electric vehicles, right? Okay. So then there are some zebra batteries which are, coming up in electric cars. So there is one company which is making this zebra batteries. So there are so many batteries in the market. You can go through the details. I can share my PPT later on. So you can go through the batteries details and advantages and disadvantages. So like zebra battery is higher energy battery. It has a short circuit tolerant and it is safer. Okay, but the problem is that only one company in the world is producing the zebra battery. So, and also it has a limited size and a capacity range, right? So it is still, the project is, still they are working on it, that, what kind of battery is more suitable, because each of the battery has its own trade-offs. So moving on to further, so we have lithium ion battery, which is right now very popular because of its high energy density, lightweight characteristics, rechargeable, and long lifespans. Okay, so this is, a popular version of battery that is being used in my electric vehicles. There are various applications in every day where I'm using batteries, like in my smartphone, laptop, wearables, electric vehicles, e-bikes, scooters, drones, robotics, and none of the area is left where I'm not using my batteries for, solar energy, for medical devices, for wind energy. So it is covering almost all domain or all aspects of the life, right? From common user to the high end user, it is covering everyone. So everyone is using the batteries in everyday applications. Now, I have already discussed this, that what is a problem. Now, since the battery is being used, now our vehicles are also using batteries. So, and we will be exploring more and more fields, with usage as it becomes, norm. We will explore more and more fields where, work can be done using batteries only. We do not need to use any, renewable. We do not need to use any other fuel or any other system. So, what are the problems? Problems without management I've already discussed. So, if I do not manage my battery on time, then these are the problems, and this will be a total disaster or a failure of my product, with, which may cause, blunders or disasters also, may take lives of people. So we can, the companies or, anyone cannot take that chance that they, install the batteries in a car without any management system, right? So there was a case study that there were in 2016 Samsung phones were there, and they were catching the fires. This was because of the battery design flaw and the poor management. Then this company has revoked, worldwide has, called for their devices. I'm pretty sure that you must have heard this in the papers, and you must have, experienced this also. If anybody would be having that, Note 7 phone in 2016, so there was a call from the company. They were revoking this product because of the poor management of the battery. The design was also flawed, as well as the battery was not properly managed. That is why it has caught the fire. So it was a huge loss to the company, to their name, to their branding, as well as it was a huge loss to people also, right? Because a common man is spending so much money, and then buying a phone and then realizing that this phone is not, efficient enough. So obviously, common man will become furious because it's a hard earned money for everyone. So it was a disaster, and no such disaster should take place in future. Therefore, we should manage our batteries. It is very essential component, right? So if I up till now, if I talk, I have just talked about the main parts of the battery. Why lithium ion is dominates the world. What happens if the battery is overcharged, and the real world battery failure example. This is my checkpoint, which I've discussed till now. So before I move on forward, am I fine with my speed, or should I slow down my speed?
Yeah,
Is it
yeah, ma'am, it is normal. We can able to get it.
Yeah, okay, okay. So now if I talk about battery management system, battery management system is like a guardian angel of a battery. Okay, just like doctor checks your pulses, heart rate and temperature, BMS also checks the health of battery, right? Without it, battery would not be able to survive or be a blunder or a disaster. Okay, so to ensure the safety and a long life of a battery, the BMS is required. Right. BMS prevents the overcharge, undercharge, balances the cell, controls the temperature, extends the battery life. Right. So, core functions of BMS are monitoring, right? So that the high voltage or a high current or a high temperature or underperforming temperature, under current do not destroy your battery. Okay. Then it also gives the protection. It prevents the unsafe conditions. If there are unsafe conditions, so battery management system should be foolproof to give you the protection. It should balance the cells, it should balance the weaker cell and the normal cells. It should balance it, right? And there will be, if there any communication is taking place, like when we are charging the battery, so a communication between a charger and a battery is taking place, right? Device and a charger is taking place. Then at that time, the battery management system should, intermediate and establish this communication in a healthy way, right? And if your EV vehicle or maybe a computer or smartphone would like to interact with the outside world, then it should give that option, and also give a healthy, safer options, like, because now we are integrating. Now we are not on just a basic steps. India has progressed in EVs so much, so even abroad also they have, Tesla and all. Obviously Tesla has started all this. India has also shown so much progress, in recent times. So lately what we are doing is we are, embedding the communication using the cloud and the edge. So BMS not only provides that communication but also reduces the risk of, also provides a security. No cyber security attacks or no hacks should destroy my battery. Suppose my car is, running, and a lot of batteries are there which are communicating with the cloud server. And if a hacker, peeps in, then what happens? They may do unethical work. Anything can be done. So this battery management system function is not just to monitor, protect, and balance, but also provide the healthy communication and a safer communication, and handling even the security aspects where it should protect the batteries. Right. Now, voltage monitoring, this is one of the basic tasks of, BMS. So voltage range, if it is too high, then it should regulate. If it is too low, it should regulate. Okay, because too high voltage will lead to the fire risk, and too low will lead to the permanent damage, right? Because too low is also not good for a battery. It will be a permanent damage of a battery, right? So this is what, voltage monitoring should be done by BMS. Now in subsequent slides or in subsequent demos, we will be covering, like, within 10 minutes we will be coming to that. So we will be seeing some codes which can be used, for voltage monitoring. How can we monitor the voltage of a battery using coding? Okay, using Ruby, right? So we will be seeing all this. Now, current monitoring. Another function of BMS, basic function is current monitoring. So it monitors the, charging and discharging, right? And then if it is a too high current, then it will be overheating. If it is too low, then it is also not good, and it also protect against the short circuits. Then there is a temperature management, which is another function of BMS, which provides, safe range, which gives the safe range for a battery to be there, 15 to 45 degrees Celsius. If it is a overheating, then it should, take the appropriate steps, so that the fire should not, take place. And if it is too cold or a poor performance, then also it should take steps that it should, heat up the battery or charge the battery, right? So temperature is also managed by BMS. Then cell balancing is also done. Cell balancing is done means, every cell, when we talk about the Tesla, I talk about the pack, which contains lot of cells, right? Cells, now this cell age differently. It is not necessary that all the cells in a pack will age at the same time, though you have appointed them at the same time, right? Because why so? Can anyone tell me why they would age differently? Even though they are, being installed at the same time, they are being given same treatment, same things, still they age differently. Can anyone tell me from the audience? Am I audible? Can anyone tell me, please?
Yeah, ma'am, audible.
Yes, please tell me. If you can tell me why every cell in a pack age differently. See, depends on the function of the cell. If the cell is used more often, then obviously it will be, it will be age faster as compared to the cells which are used less, right? Right? Does it make sense to everyone? So I'm assuming it makes sense. Okay, because there is no, so it is making sense. Now onwards, I will assume so, right? Because audience is not interactive with me. I'm not.
Ah. No, ma'am, will don't know. They will answer you. I think
Okay.
most participants are still there only. Maybe we'll see. Next question they will answer. Sorry.
Okay,
Okay.
fine. No, the problem. I know it
Okay.
is, very hard at this point of time attending the session. You've already been, it's a
Yes.
whole day, whole working day for
But
you.
very interesting. Their session is very interesting, ma'am. It is
Thank you.
interesting to
Thank you
listen.
so much.
Okay. Okay.
Thank
Okay.
you. Your
Proceed.
interaction and your motivation will make, this session more
Ah,
powerful. You can
okay.
give me the power. The
Yeah. Yeah.
audience can give me the power.
Okay. Thank you. Thank you, ma'am.
Yes, you can charge my battery. So, so cell balancing is very important aspect in battery management system, and we will be looking forward to the code of this cell balancing. How to balance your cell. I will show you the code. We will work hand in hand together. I will give you the link. Please open that link. I hope everybody is having the laptop or a system, where they can work along with me, right? So cell balancing, cells age differently. Some charges faster, some discharges faster. So BMS, make balance between them. There are some cells who are very active and some cells who are passive. Like, some people in audience group is very active, and some people are okay, fine. And we are understanding, but it's okay. We are not in a mood to answer. So it is like a cell. Okay. So then communication, another aspect, BMS will do is communication. It provides a communication between a charger and, controller. BMS is responsible for establishing that communication, right? Then there are lot of protocols that are there, while your EVs batteries are communicating with a charger or a controller, microcontroller, right? So there are so many protocols, even outside world, not only with the charger or a, microcontroller, but batteries also interact with the outside world. If my, there is a, I'm I'm getting that battery management services from the cloud computing or edge computing. So it will be talking to the outside world also. So there will be lot of protocols that are used, but few important protocols that are used in this communication is CAN, UART, and 12C. Right. So you can further explore this part more. And if you feel like we can discuss, I will be coming in next lecture on Friday. So we can discuss this protocols. Already I'm having 87 slides. So to cut it short. So I have, it's not expanded this topic. So there are a lot of protocols which are, which are being used, and BMS act as a translator between your device and your charger, maybe, right? Your device, your battery and a charger, or maybe with a cloud and a battery. So it acts as an intermediary. It acts as a what should I say, intermediate. It intermediates that communication using the protocols, right? Am I right? So
Yeah,
moving
ma'am.
on further, uh, uh, just give me, just 1 second. You have to bear with me, okay? Apologies for that. Apologies. Yeah. So BMS, if I talk about BMS in everyday life, so battery management system is needed wherever I have a batteries, like in smartphone, laptops, EVs, renewable. It is a renewable energy, wherever I'm using the batteries, So I need that battery management system. Okay. Moving on to further, up till now I have discussed like BMS functions, cell balancing, communication protocols that are used in BMS, and where do we see BMS in daily life, right? So this is what I have, taught you. If we look, BMS functions just beyond monitoring, it also take decisions, intelligent decisions, smart decisions, right? So it takes decision like, are you aware of SOC and SOH? Is the audience aware of SOC
Yes,
and
yes, ma'am.
SOH? Please.
SOC is state of charge of the battery, and SOH is the state of health of the battery.
Yes. So for
In mobile phone, if
yes,
we
yes,
charge
yes.
the mobile phone, it is 100%, 50%. That is SOC.
Yes. Yes, so state of charge and state of health estimation, So based on this estimation, taking some decision, is a BMS function only, right? To ensure the safety of, batteries, so that it is not hacked. If something is coming from the cloud, it is not hacked, or to ensure the safety also, otherwise also, overcharging, undercharging, safety against the fire, safety against a disaster. Again the BMS will take some decision, right? Okay, so BMS is not only just monitoring, it is also taking some decision, and it also ensures performance and reliability. Now this I will also show you through a demo that how my BMS, is ensuring the performance, how my BMS is if I'm managing the battery through Ruby, how it is giving me better performance, right? So there are some safety functions which BMS does, is like, emergency shutdowns, thermal runaway prevention, right? So it acts, in a layman language, if I say, it acts like an airbag. Okay, if anything goes wrong, too hot, too high, too cold, whatever, it cut off the charging. It shut down the system. Okay, so that any further damage should not happen. One of the solution, if nothing is coming up, the only thing BMS do is shut down the system. Okay, now as sir also pointed out, as sir also said rightly, that it is SOC is state of charge, right? So state of charge is a percentage, how much charge is left, how much percentage of charge is left, right? For example, phone showing 80% battery. So how much is remaining, so how long, it is very important in EV vehicles. Why it is important in EV vehicles? Because it tells me that without charging how long I can drive, how long my battery will work. Okay, then comes the SOC estimation methods, state of charge estimation method. Now there's various methods, like Coulomb counting, which tracks current in and out. Now, what do you mean by current in and out? How much current has, been flown into the battery and how much is taken out of the battery. So simple calculation, suppose I've given the battery as, 1 Ah as a current, and I'm taking out the 0.5, then the remaining definitely is 0.5. Okay, so if SOC estimation, how SOC estimate that how much battery is left, how much it is used or how much it is left, how it estimates? It estimates using these methods, Coulomb counting, where it tracks current in and current out, right? Then there is a voltage based estimation. So it matches, it estimates using a voltage curve of the battery, right? And then there is a hybrid approach which combines various methods to estimate SOC, like voltage, current, temperature, historical data. Okay, and it uses the Coulomb filter to avoid the noises and improve the accuracy. Now over here there are many machine learning algorithms are also popping up nowadays to estimate SOC. Many new advancements are coming up for this SOC estimation. So another factor is state of health, right? State of health is how much your battery has aged. Okay, state of charge is how much battery is remaining. State of health is how much battery has all aged. Its life is how much it is aged. Okay, for example, if your battery, if you have a phone, okay, whose SOH is 80%, right? So it won't last as long as new, right? You bring a new phone, it gets charged very, rapidly. And over the period of time, you will realize that your phone is taking time to get charged. So that is state of health, that is a battery aging, right? So how much? Now, EV manufacturer guarantees that battery SOH above 70% lasts 8 to 10 years. So if any battery in EV vehicles have SOH as 70%, greater than equal to 70%, then it will last 8 to 10 years, right? So there, now as we had SOC estimation methods, we have SOH estimation methods also. So SOH estimation methods are like, they track the charge cycles, they measure the internal resistance, they compare the capacity that was, when it was originally taken as, and now my battery is ticking. So these are some of the methods, which SOH will be using for measuring, for estimating the SOH, right? Now, BMS algorithm, battery management system algorithms, though they use various mathematical models and nowadays even AI based algorithm for finding the accuracy, right? For finding SOC, SOH and other things in BMS, batteries, right? So why these models are needed? Why I need to, check the SOC and SOH of my battery? Why this is needed? Because can I not sense it? Can I not sense it? Why a model is needed? Can I not sense it? I can sense it, but sensor will give me only raw data, the voltage, current, temperature, right? From these raw data, we cannot just assure the state of charge, state of health. We need to apply some algorithms using this data. We can, with the algorithms, we can, with the help of this data and algorithms, we can, measure SOC and SOH properly. Right? Is it clear?
Yeah, ma'am. Yeah, it's clear.
There are several models, like equivalent circuit models, like electrochemical models. There are several models, which run and check SOC and SOH for batteries, right? Then there are some AI based models also, like support vector machines, reinforcement learning. Though they are they are also being used for measuring the SOC and SOH of the batteries. Now, this is a normal diagram that is explaining me that how this SOC and SOH estimation is done. First, sensor collects the raw data like voltage, current, temperature. Arrows are, sorry for this, arrows are, in a wrong direction. So first sensor and voltage, current, temperature is taken. This is a raw data sensor collected. Then this models, models with this data, work and will tell the estimation. Then on that estimation, we cannot assure even at this stage also that estimation is correct. Some filters are applied to remove the noise, unnecessary noise. Like Kalman filter is very common, right? Then extended Kalman filter is there. Then neural nets are there. Then some AI support vector machine and reinforcement learning algorithms are there, which remove the noise and will give me the exact SOC and SOH of a battery or of a cell. This is needed, right? SOC and SOH. Regular checks are also done on batteries. So this is needed to find, what is the state of the charge and what is the state of the health of a battery, right? So, why we should do this estimation regularly. Yeah, why this is being inbuilt. EV vehicles inbuilt done this at shorter intervals. They check this SOC and SOH. So why this is inbuilt and why it is being checked, because again, to prevent any overheating or a disaster or an explosion, right? So BMS, as you have just seen, that BMS is not only just monitoring, but it also takes the intelligent decisions also, right? So like in Tesla, Tesla is not just famous for its like so many miles it can last, or so many very good car with a very good features, but it is also famous for its battery management system. It has one of the best battery management system installed in their cars. So that is why Tesla is very safer, very safer option, but at the same time it is costlier also. But in India we are trying to have BMS like a Tesla, and yet the cost is less. Cost should be less, right? So moving on to further. So if up till now I have discussed SOC and SOH, then there are some SOC estimation challenges. What is a thermal runaway, and some algorithms used for SOC and SOH, right? So if I talk about now architecture, everything is architecture. It is not just a pack of batteries which I'm just installing, but it has a proper architecture, where I need to put my battery, what is the architecture and how it will interact, right? So like there are several ways, several architectures. The one is the centralized BMS. Centralized BMS says that you have a single controller, okay, single controller which will monitor all the cells, okay. And what you need to do is you need to interact with this controller to manage the batteries all over, right? It is simple, lower cost, right? But it needs heavy wiring, okay. And if for any reason this controller fails, then every function is failed, right? Its scalability is limited because lot of wiring is needed. It will be a complex. If I increase, uh, if I increase the size, if I try to install more and more cells, if I try to connect with the centralized BMS, then what happens? Because of the heavy wiring, I would not be able to. Right. So scalability is low. So this is few disadvantages of this type of architecture. Then there is a battery management system which is modular or distributed. Now in this there are different modules. You have divided the modules. Okay, one module for running your car, one module for giving you the uh, alerts, one module for checking the performance. So different modules, you have different batteries running, different modules in a different modules, right? Different modules are running, and these modules have their own controller. Each module will have their own controller, and this controller will work with a central system or a system controller. So there will be one system controller and multiple controllers, module controllers, right? So its benefit is that it is scalable, easier to maintain, shorter wiring. But disadvantage is that it is higher cost, more complex, and this communication does not come easy. You cannot make one module communicate with system controller or the other communicate other module, because it all modules, sometimes two or more modules have to work together, right? At the time of emergency, the car must stop, right? And then a warning message must appear. So more than one module has to work hand in hand. So communication should be established between them also. So this is again, very complex, complex communication, and the cost is also high because we have a modular design. Then there is a concept of master slave. You must have heard this concept of master slave in digital electronics. So in master slave, central master supervises multiple boards. Okay. This concept, balance between the scalability and the cost. And it is often used in EV, drones, stationary storage, and many other systems. Right. So master slave is one master, many slaves, and over here they can reverse the role also sometime. So this is used in EV. Again, master slave, can be elaborated over here. Is there are more architectures under master slave, depending, like they are reversing the role, they are not reversing the role. There are so many architectures inside it which you can explore, right? So now the what while designing this BMS architecture, what we should see, we should see the cost. Cost is very important, and complexity is also important. So there is a trade-off. If the cost is high, complexity is low. Complexity is high, cost is low. So we need to come in between solution between cost and complexity. We need to come in between. We need to decide about that whether we want scalability or we want simplicity. Okay, we need to, this is a challenge, this is a trade-off when you're designing a BMS architecture. Then redundancy or a single failure risk as in centralized BMS. Okay, or then I talk about where there is a multiple controller, multiple module controller, that is a redundancy, because you're constructing many controllers and then also they are interacting with a single controller. So you want a redundancy, or your appetite is to take the single failure risk. So it depends on the application, right? It depends on the application to application, as well as depends how much cost you would like to put in over here, and how much safety you can compromise to. So this is, these are some of the trade-offs which are the real challenges, on which many researchers are working. So to give the best hybrid solution. Okay, so they are working that, though the cost should be less and complexity should also be less. So they are working on these trade-offs. Then there are some safety standards for BMS, like, ISO 26262, IEC 61508, which is for general safety. Then UL 1973, which is for battery safety. Okay, specifically for battery safety for energy storage. So these are few standards for BMS. Moving on to the further, so I've already discussed that these are some of the communication protocols which need to be take care when my device is communicating, when my batteries are communicating. So these are the protocols, whether they are communicating internally, they are communicating with the externally, with cloud, or maybe with any other application. So these communication protocols come into picture. And nowadays, wireless BMS, which is very popular trend because it reduces the wires. So this communication protocol also need to be taken care of while designing your EV car. Okay. So, but over here, the problem is that wireless BMS, are they safe enough? Are they safe enough to handle the cyber security threat? We need to check this. Cyber threats can happen to wireless BMS. So, um, cybersecurity threats, as I discussed, so there is a risk of hacking the EV batteries. So if I hack the EV battery and I let EV battery perform, uh, unethically, then it will be a disaster, right? Or how I can ensure that my BMS communication is secure? I need to encrypt and secure my updates, right? I need to disable remote disabling of the stolen EVs. So I need to disable the batteries. If the EV is stolen, then I need to disable the batteries also. So there are so many challenges, that is coming up with the new advancement like wireless BMS. Many challenges, and lot of scope for academician to work on these areas, to build their research profile or a portfolio. So now, coming on to the main thing, Ruby. Okay, Ruby is a language. Okay, it is a high language. It is interpreted. Okay, it focuses on readability, simplicity. Okay, it is used in web development, automation, data processing, and many more applications. Now, why I'm using Ruby? Okay, why I'm not using Python? Okay, that is another question. Why I'm using Ruby? Why I'm not using Python for battery management system? This will come in subsequent slides. I will tell you. Okay, before I proceed with the codes, I want everybody to open this, code. Just give me 1 second. I'll put it in a chat. Is it fine?
Yeah, ma'am, you can able to get it, ma'am.
Uh, I'll put it in a chat.
Chat box, ma'am. Yeah, okay.
Putting it. You can open this, or I'm putting one more link. Any of the compiler or interpreter for Ruby, whichever you are comfortable with. Is this fine? Is this visible to everyone? Not my presentation, but this, editor of Ruby. Is it? Is it on my window? Is it on my screen? Is it visible, this editor?
Yeah, visible, ma'am. Visible, ma'am. Yeah, getting it.
Okay. So we will be doing some demos. Okay.
Oh,
So
okay.
I'm starting with the, very basic, first of all, if I start with any language, I must know how the variables are declared, how they are used, how is conditional statements are given, how functions are used, arrays are used. So I'm starting with the basic and moving on to further. Okay. So like this, suppose you have written, sorry, you have written voltage equal to 4.2. So voltage is a variable. You can give any name over here, X, Y, Z, A, B, C, D, and its value is 4.2. You do not need to put any data type over here. Okay. And when you run this, see, it gives you the value. Okay. Right.
Yeah, ma'am. Yeah, ma'am.
Is everyone with me? Is everyone doing with me?
Yeah, ma'am.
Okay. So now this does not make much sense to me. So like, giving the value of the variable. Let us do one more thing. I am writing. I'm changing the value over here. Let us make it 4.3. So my code says if is a condition. I hope everybody is aware of this condition. So if voltage is greater than 4.2, then puts stop charging. Puts is to show the message. So when you get the alert on the screen of the EV vehicle, so this is what is happening. It is putting the message over here. So it is giving the message stop charging. Plus, you can, add on to it and you can instruct C programming C, which is built over the Ruby to, switch off, switch on and, switch off the charging, cut off the charging. MOFSET, you should close the MOFSET. Okay, I'll show you in further subsequent demos. Just a simple example over here. If the voltage is greater than 4.2, then it should show me the message of stop charging. So I'm running this. So see, since my voltage was 4.3, I've changed it and it is greater than 4.2. So it has shown me stop charging. Is everyone with me? Now, what is the case if I put a 4.2? Okay. Now 4.2 is not greater than 4.2. See, it's not giving me any output. Is it fine? Shall I proceed?
Yeah, ma'am, you can proceed.
Okay. Now, if I am checking the battery and I want to check it, multiple times. Okay. See, 3 dot times 2. Okay. Check the battery 3 times. Okay. And every time display, puts means display. Okay, display the message. So puts checking battery. So 3 times it is displaying with a message. If you want, you can change it to any value you want, 10 times maybe. 10 times it should check the battery. So see, it is checking the battery 10 times. It is giving the message 10 times. Okay. Is it clear? Moving on to further. Now I want some function. Okay. I want some function to be there. Functions. So how you define functions in Ruby? You write function as def. Okay. Def. And you end your function with end. You give the function name over here. And if you want to give some value, you can give the values also here. Any values you can give. Any variable or values you can give. So I have defined one function. Let me, remove this. Otherwise 10 times it will, print that message. So I have defined this function stop charging. And I'm saying that if this function is being called, it should give me the message as charging stopped, right? So I'm calling this function. Sorry, it should be inside the main. Sorry. I'll call it in the subsequent. should be inside the make. Wait. I'll integrate further. I have done that. Wait. I've done in the subsequent, I'll tell you. So this is just to tell you that how the function is being, declared. Define, stop charging, put and end. Right? Def is a function, when you say in the C, you write function, over here you write def. Okay. Then the function name. Okay. I'll proceed forward and I'll let you know this error. I'll do that. So moving on to further arrays. Okay, let's do the array. So over here, I have an array with the name cells, which has a value 4.0, 4.1 and 4.2. Now this array indexing start from 0. So this is the 0th one, this is the first one, this is the second element. 0, 1, 2 means 3 elements in total and it's starting from 0. Okay. Now every time I want to put, I want to display the voltage, every time it should loop over each of the array element and give me the voltage value. So with this syntax, it is doing the same. So see, cells dot each do v means it should loop through this array with the name cells, and every time it should do what? It should give me it should display the message as voltage hash v means give the value of v. Okay, it should give me the value of v. Is it clear? Right? So it should give me the value of v. Am I clear to everyone?
Yeah, ma'am.
Moving on to further. Now, as you have array, okay, you have hash in this also. Hash. So what is the difference between an array and a hash is that battery over is a hash. Okay, what is there? You are not just writing the values. You're not simply writing 4.0, 4.1, 4.2. You are assigning these values to particular variables. Like I'm assigning to the voltage. Voltage is a variable. I'm assigning it a value as 4.3 and 25 to the temperature, which is TMP in my case. So you can put X, Y, anything over here. Now I'm checking the condition. If battery voltage like this, I'm checking if the battery voltage is greater than 4.2, then it should give me the message stop charging, which it will do in my case. Look at this. Right? Is it clear? And if I write, if battery temperature is less than 26, then it should give me stop charging. Stop charging 1. I'm just changing the message. Okay, you can give any message. Is it clear? So Over here, I can give what I want. This is a hash. This, first line is a hash. This is a hash. And what is the difference between an array and a hash? Over here, I can, like in enumeration, I can assign the, values to variables or, values to any literals, I can say. Values to any variables or literals. Okay. So moving on to further, now there are several combinations you can try by yourself. When you want voltage also, as well as you want temperature also, what you should do. Can you try? Can you tell me if I want to check both the conditions? What should I do? There are several combinations to it. Okay, so this is one of the tasks, you can check it at, at your own meaningful time, where, you want a voltage check also and a temperature check also. So moving on to further. See, this will, give me some error. Okay, let us be prepared for it. Says that I have an array with the name cells, and the values inside this array is for each element is 4.0, 4.1, 4.3. Okay, now I am again looping this, array for, voltage, and, there is some variable I. Okay, I'm looping it, for its index and the voltage. If voltage is greater than 4.2, then what it should give me the message, cell number I plus 1. Now, why I plus 1? Because we are starting our value from the 0. Okay. So, 0 should become 1. So, cell number, whatever the number that will come, over voltage, stop charging. Okay. And it should call this function stop charging. Now, the problem is that this function is embedded in C. And where is that C function is? In the firmware. Okay, so it is embedded in firmware. So that is why the call is not happening. Even in that scenario, the call was not happening because this is not the Ruby part. When I'm calling this function, it is calling the C function, which is embedded in the firmware. And when this function will be called over there, then it will take the appropriate action. Maybe it will ask the offset to switch off. Okay, to flip. It may ask the offset to flip. Okay, so let us run this. See, it is giving me the error. It is giving me the message. It is running fine till here. See, it is running fine. Cell 3 over voltage, stop charging. It is giving me this message. But after that, it is an error that we have seen earlier also. Because this is a function call of C and I'm working on just the Ruby. I'm not, integrating it with C. Okay, right? For that, I need a proper firmware. For that demo, I need a proper firmware. But for that also, I have found one solution because I had to give you one demo. So I have found one solution. Let us explore that. It is clear up till now. It is clear up till now.
Yes, ma'am. Yeah.
I want to hear more from, other audience, other people. It is clear?
Yes, ma'am.
Okay. If you have any doubt at any point, please, I'm here to just resolve your doubts. Please, stop me then and there and please ask me. Now see, now the problem we were encountering is that this, again, I think I've copied the same code. Wait. Now with this code, no, I am not. So the problem was that if I'm calling this, stop charging. So right now, at present, no firmware is connected, right? I cannot test it, whether it works or not. Now I have simulated this in Ruby. Okay, I have just to give you the how it works, I have simulated in Ruby. See what happens. I have put two functions. I have made two functions. One is stop charging and one is reduce charge current. I have made two functions. How I know it is function? Because I'm starting it with def. Okay, def is a keyword for the function. So I'm starting it with the def. Inside this function, I have put some message. Okay, when the code start, you can put anything message like triple greater than, you can remove also. So it is up to you what message you want to give over here. But actually what happens, the message is displayed as well as the offset is switched off by the C. Sorry. Then what happens in the second function, if you see, there is some parameter also, which is called factor. So second, whenever I call this function, I will also give this, the value, some value over here. A parameter is there. So the purpose of this script is to show you, how functions can be created with the parameter and non-parameterized. So over here, I have an array. This is an array. This is not a hash. This is array. Okay. Now with the array, I am doing a indexing. Okay. Now with each cell, what you do, you check the voltage, you check its index number. So if the voltage is greater than 4.2, let's check it one by one manually first. So if in the first go, what voltage it will have? 4.0. And what will be the index number? 0. Right? Am I right? So it will be 4.0 and it will be 0. Okay. So if 4.0 is greater than 4.2, is it greater than 4.2? No. It will not do anything. It will come out of this loop and then again it will go back and loop my second index. Now second index means what is the value of voltage? 4.1 and index is 1. I is 1. Check. If voltage is 4.1, if 4.1 is greater than 4.2, no, not in my case. So it will come out of the if. How it will come out of if? It will come out of this end. Okay. Now it will go again back. It will loop until entire array elements are being checked. Okay. Now what it will do? It will again check the third element. Okay. Now this third element is 4.3 and index is 2. Now this voltage is definitely greater than 4.2. Then if it is greater, then what is to be done? A message to be displayed which says cell number, which should start with Ruby as in parenthesis, and then cell number 3 over voltage, and then it should call two functions. First function calling is stop charging, and it will go to stop charging. Now in stop charging, again a message is there. So it will give me this message, charging stop. Then it will call the another function which says reduce charge current to 0.8. Okay. So this will call the second function and it will give the value 0.8 to this factor. And it will give me the message, see charge current reduced to 0.8 into 100. That is what? 0.8 into 100 is 80. And then a percentage sign is there. So charge current is reduced to 80%. Okay, because it was over voltage, so charging current is reduced. A decision is taken by BMS to reduce it. So see, all the messages being displayed. Okay. Any problem, any doubt?
Participants, if you have any doubt, you can raise it.
Moving on to further. Now you can do a lot of combinations here. You can try 4.3 here, putting 4.1 here, so that, second element, as soon as it lands up into the second element and it should get this, then what happens, will it loop to the entire array and all? I'm leaving all this exercise up to you because we are running out of time. So, I have to tell you more. So I'm putting that exercise for you. Now, this was when I am simulating C firmware function into Ruby. Okay, I am just trying to simulate, stop charging into Ruby. Now, what happens if the actual C firmware function is there? See. Big code. Now over here, it will show me some error. Be prepared for it. So, I am trying that, it should call the offset and all, but I don't have a firmware. So how it will communicate with my firmware, right? So obviously it will show me the errors, right? If I want to simulate, sorry, if I want this stop charging to, actually stop the charging, not just, give me this messages. If I say over here that stop charging, then this stop charging should go to the firmware and do the actual work. Then it should, I should have firmware, interacting with it. So it will give me some messages, over here, because I have simulated this C function. This is a C function. See this? This is a C function. Stop charging is a C function which I have simulated in Ruby. Okay, I have put it in a Ruby fashion. I have written in a Ruby style, mruby style. That is why it is giving me the output. But, if I want actual, then I should, make it interact with the firmware. Is it clear? So, this is how the working. Can you see my slide? Can you see my slide? Everyone can see my slide?
Yeah, ma'am. Yeah, ma'am. We able.
So you have seen that, with mruby, you can, do lot of functioning. You can protect your over voltage and so many things are there. So you can do that. Is it happening in real? Yes, it is happening in real, right? And if suppose mruby is not there and you are just interacting with the C function, pure C function, like stop, charging. You are just interacting with the C function. You do not use mruby. Then what will happen? Every time you make changes, in your code, you need to recompile. So in a firmware, to recompile the firmware is very, costly and a difficult task. So why not make the changes in mruby and then let that function interact with the C? Okay. So you have to just, every time, otherwise every time you change the logic, you need to, recompile the firmware. Okay. That is, again, a costly affair and time consuming also. So how my architecture is basically, you have a logic script as it is written. It interacts with mruby interpreter. Okay, it is an interpreted language. It's not compiled, it is interpreted. So interpreter, and then this mruby interpreter output will interact with the core BMS firmware in C. It will interact with the firmware which is written in C language. Then based on whatever the result is, then that will interact with the sensor data or a commands, and it will interact with the battery hardware. So this is actually the flow of the code is happening. This is the actual flow of code is happening, where you are interacting with the battery management system. Okay, this is a flow. So Ruby is basically a layer above the C function, which is inbuilt in the, which you have done in the firmware, which you have written in the firmware. Okay, right? So moving on to further, I will take 10 minutes more. Okay, is it fine with the audience? I'll show you more codes, more practical codes. Now you have to send the alert messages. Suppose you have to send the alert messages. So if depending on the what I've done, depending on the SOC value, right? If the SOC value is less than 20, then you are putting some message and you're sending an alert that battery is low, please charge soon. You're sending an alert. Else, what you should do, what you should give the message that SOC is okay and this much percentage of SOC is there remaining. Okay. So in my case, since I put the SOC as 18, the value was 18 and 18 was less than 20. So it displays me the message that SOC is low and it is 18% and battery is low, please charge soon. So, and as well as what it will do, it will, uh, uh, ask the C, firmware in the C to perform, to take some action corresponding to this low battery. Okay, not just showing me the message but also take some actions also, take some intelligent decision also at your part. So this is what is happening. Then there are some codes which I can share for balancing the cells, then protecting the cells. Then there is a code of open relay, right? So there is so many codes, I can share all these codes if you want. So should I, continue or should I, share these codes for you? Share the codes with you. Am I audible? Am I connected?
Audible, ma'am.
Please let me know. Should I share my codes with you so that you can run? I've shared my compiler. I've shared the,
Yeah.
link of compiler also so that you can practice at home, or should I, continue with my practice?
Yeah, ma'am. Sure. If you post means the
Audience,
participants and we too also can able to practice.
as per audience, point of view, please vote faster. Should I continue with my codes? Should I show you the codes, or should you will you do it at your home and we'll discuss it in Friday when I'm coming for the lecture?
Let me check in new you, ma'am. Participants, shall we proceed or we can see it by next Friday, next section, on the next section?
Please write it on chat box, please faster, so that it should not waste your time and anybody else time. So one of ma'am is saying next session. Okay, I will share this file over the WhatsApp to ma'am or
Yeah,
sir.
sure, ma'am. You just share to us. We will share in that WhatsApp group so that they may practice. If there is any doubt, means they know you on the next section.
Yeah. Please practice these codes. These codes, are very small codes, but yet they are very powerful codes. I'll share my PPT with you all also, so that you can grab the concepts. So I hope the session was meaningful for everyone, and
More informative, ma'am. Really, but
thank
time
you.
is not sufficient to get more about.
Yes. So I have lot of things to tell you, lot of demos to give you. I have prepared almost 20 to 21 demos, and lot of demos are still left to give you. But since there is a time constraint and everybody, I think, is now tired, so I'm ending up the session here. I'm giving you all the resources, whatever I can. Anything, any doubt or anything regarding the session, any feedback, you can give me on Friday. Okay. Thank you so much. Thank you for having me.
Sure, ma'am.
Can we have
Really,
one?
session was
one
informative, much more informative. Since we people must not have a more idea about the Mulberry, but somewhat we learned a huge, ma'am.
Thank you so much. I have shared two meaningful links with you also, not only the interpreter, but two more links are there on my PPT, where if you want to learn the Ruby for battery management system specifically, so it is very powerful, very light, you will feel very light. You will feel like, I'm learning it in a happy mood, like, ABCD type. So you will learn everything and it will be very, very light for you. So I will share that PPT. Yes, sir. And yes, ma'am, I will share. Okay, can we have one picture as my memory? Everybody, please, if possible, please turn on your cameras. One picture.
Participants, kindly unmute your camera.
Yeah. So that is my memory with you all. So one picture, please, everyone, please. Sir, can you take this picture and share
Yeah, ma'am.
over?
Yeah, ma'am. Yeah, ma'am. Participants, all of you kindly unmute your camera. Okay, thank you, thank you.
Thank you, everyone. Good night. Have good sleep. Okay. Bye. Thank you.
Thank you, participants. Kindly fill up the feedback link which is posted on the chat box. Hello. 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 முடிஞ்சிச்சு சார். கட் பண்ணலாம்.